Class 10 Subject Chemistry Chapter 2 Acids, Bases and Salts Module 6 Objectives. At the end of this class, you will be able to define hydrated salts, explain water of crystallization using an experiment, know preparation of plaster of Paris, list properties of plaster of Paris, and list uses of plaster of Paris. Water of crystallization. Hydrated salts. When salts form, there are sometimes water molecules loosely attached to the ions in the crystal. A hydrated salt is a salt which contains water, or the salts which contain water of crystallization are called hydrated salts. Every hydrated salt has a fixed number of molecules of water of crystallization in its one formula unit. The number of water molecules involved is shown in a dot formula. Example, hydrated copper sulfate has the formula CuSO4.5H2O. It is called copper sulfate pentahydrate. Pentahydrate means 5 molecules of water. Sodium carbonate crystals contain 10 molecules of water of crystallization per unit formula and hence written as Na2CO3.10H2O. This is called sodium carbonate decahydrate. Decahydrate means 10 molecules of water of crystallization. Calcium sulfate crystals contain 2 molecules of water of crystallization in one formula unit and hence written as CaSO4.2H2O. It is called calcium sulfate dihydrate. Dihydrate means 2 molecules of water. Iron sulfate crystals contain 7 molecules of water of crystallization per formula unit and hence written as FeSO4.7H2O. It is called iron sulfate heptahydrate. Heptahydrate means 7 molecules of water. It should be noted that water of crystallization is a part of crystal structure of a salt. Since water of crystallization is not free water, it does not wet the salt. Thus, the salts containing water of crystallization appear to be perfectly dry. The water of crystallization gives the crystals of the salts their shape and in some cases imparts them color. The water molecules which form part of the structure of a crystal are called water of crystallization. Or water of crystallization refers to the water molecules in a hydrated salt. Here you can see the picture of some hydrated salts. Action of heat on hydrated salts. When hydrated salts are heated, the water is driven off and the compound left is referred to as the anhydrous salt. Example, CuSO4.5H2O on heating gives CuSO4 plus 5H2O. Let us do an activity. Heat a few crystals of copper sulfate in a dry boiling tube. What is the color of copper sulfate after heating? We observe that color of copper sulfate changes from blue to white on strong heating and also form water droplets on the sides of the test tube. Add 2 to 3 drops of water on copper sulfate obtained after heating. What do you observe? Is the blue color of copper sulfate restored? Yes, copper sulfate regains its original color. From this activity, we conclude copper sulfate contains water of crystallization. Plaster of Paris. Plaster of Paris is calcium sulfate hemihydrate. The formula of plaster of Paris is CaSO4.2H2O. The name plaster of Paris came from the fact that it was first of all made by heating gypsum, which was mainly found in Paris. Plaster of Paris is commonly known as POP. In the preparation of plaster of Paris, heating of gypsum should be controlled carefully. The temperature during the heating of gypsum should not be allowed to go above 100 degrees Celsius or above 373 Kelvin. This is because if gypsum is heated above 100 degrees Celsius, then all its water of crystallization is lost and anhydrous calcium sulfate called dead burnt plaster is formed. The anhydrous calcium sulfate or dead burnt plaster does not set like plaster of Paris on adding water. Note: in the formula of plaster of Paris, only half a water molecule is shown as water of crystallization. It is not possible to have half a molecule of water. The formula CaSO4.12H2O actually means that two molecules or two formula units of CaSO4 share one molecule of water. The formula of plaster of Paris can also be written as 2CaSO4.H2O. Properties of plaster of Paris. Plaster of Paris is a white powder. It has a very remarkable property of setting into a hard mass on wetting with water. So when water is added to plaster of Paris, it sets into a hard mass in about half an hour. It is due to hydration to form crystals of gypsum. CaSO4.12H2O plus 1.5H2O gives you CaSO4.2H2O. Why should plaster of Paris be stored in a moisture-proof container? This is because the presence of moisture can cause slow setting of plaster of Paris by bringing about its hydration. This will make the plaster of Paris useless after some time. And now for the uses of plaster of Paris. It is used in hospitals for setting fractured bones in the right position to ensure correct healing. Plaster of Paris is used in making toys, decorative materials, cheap ornaments, cosmetics, blackboard, chalk, and cast for statues. Plaster of Paris is used as a fireproofing material. It is used in chemistry laboratories for sealing air gaps in apparatus where airtight arrangement is required. Plaster of Paris is used in making surfaces like the wall of a house smooth before painting them, and for making ornamental designs on the ceilings of houses and other buildings.